Welcome to lesson 1.5, solving inequalities. Your objective is that you can solve and graph inequalities and that you can write and solve compound inequalities. An inequality is like any of these where we have greater than, less than, greater than or equal to, or less than or equal to. So the first one is x is greater than 4. We can plot a 4 on the number line, and since it's only greater than 4, then we do an open circle. And I would like for you to use this style of graphing, so send a tail above this number line and over to the right, and send that arrow just about as far as the arrow on the graph. Okay, these little details are going to be important later. X is less than 4. All right, put a tally at the 4, open circle, and a less than. So everything lower is part of the solution. So this is saying x is all numbers bigger than 4 and not equal to it, but bigger. So then we head to the right on the number line. That it means includes 5, 6, 7, 8, all the way up to the hundreds and thousands and millions. X is less than 4 is every single value that's less than 4 is a solution. So it includes 3, 2, 1, 0, and all the negatives. X is greater than or equal to 4. That means we put a tally at a 4. Close circle this time, meaning that it could be equal to 4 or anything bigger than it. And then we go to the last one, x is less than or equal to 4. So we put a tally at the 4, close circle, and less than or equal to is everything lower. Okay, so it's a whole interval of millions and millions of answers. Okay, solving an inequality is similar to solving an equation. However, with an inequality, when you multiply or divide both sides by a negative number, you need to reverse the inequality symbol. Okay, so for example, multiply each side of the first inequality by a positive number, and then multiply each side of the second inequality by a negative number. So we're going to just times both sides by 2, which is something that we can do due to the property of equality. Is whatever you do to one side, you have to do the other. So this gives us negative 10 is less than 20. Now the first inequality here read negative 5 is less than 10, and that is true. Negative is less than a positive. When we times both sides by a positive, we still get a truthful statement. Okay, in the beginning we have something truthful over here. But when I multiply both sides by something negative, times negative 2. Negative 5 times negative 2 is positive 10. 10 times negative 2 is negative 20. And this time, 10 is not less than negative 20. In order to keep the inequality saying the truth, we must reverse the symbol whenever we divide or multiply by a negative. Okay? Dividing or multiplying by a positive is fine. Dividing or multiplying by a negative means we have to reverse the symbol to keep the symbol true. The 10 should be bigger than the negative 20 in symbol form here. Okay, so we must reverse that symbol to keep our inequalities saying the truth at all times. Okay, solve the inequality and graph your solution on a number line. As you see, we have multiplication into this grouping. Plus 1 is greater than or equal to 4. Go ahead and distribute first. Negative 6x plus 15 plus 1 is greater than or equal to 4. Because you didn't multiply or divide both sides of the inequality by a negative, then you don't have to switch this inequality here. Okay, we just distributed on one side just to simplify. and to combine that in to get our grouping symbols combined, to get rid of our grouping symbol. Negative 6x plus 16 is greater than or equal to 4. Okay, subtract 16. Negative 6x is greater than or equal to negative 12. And divide by negative 6. What do you notice? You divided or multiplied by a negative, so you have to switch that inequality symbol. So what was greater than or equal to now needs to be less than or equal to 2. Okay. So then we plot a 2, close circle because it's less than or equal to, and head to the left. All right, both this and this are your solution. Okay, let's go over to B, solve. All right, let's add 5 minus 6x. We get x is greater than 9, just like that. At the 9 then, is it an open or a closed circle? It should be an open circle. And x is everything greater, so head to the right. Okay, please adopt this style of open or close and using your arrow up above the number line and extending it all the way, and you'll see why in a moment. Okay. The solution set for an inequality can also be described using interval notation. The infinity symbols positive infinity and negative infinity are used to indicate that a set is unbounded in the positive or negative direction. Parentheses are always used with positive infinity and negative infinity because they do not include endpoints. So let's talk about a couple of scenarios here. Case 1, to indicate that an endpoint is not included in the set, a parentheses is used. For example, x is everything less than 2 in interval notation is negative infinity to 2. Because on the number line, x is less than 2 is trying to say that everything less than 2 is a part of the solution. So in interval notation, we go from low to high, and we represent the whole bounds of the solution set from low to high in that order. So this is your solution set, everything less than 2. And from low to high, we think of it as negative infinity to 2. Negative infinity is the low end, 2 is the high end, and those are the two outside ends of the solution set. Okay, everything down to negative infinity and only up as high as 2. Okay, to indicate that an endpoint is included in a set, a bracket is used. So x is everything greater than or equal to 2 this time. Then we would close circle at the 2 and head to the right for everything greater than or equal to it. And in interval notation, we would say from low to high that this solution set goes from 2 to infinity. And it's a bracket this time at the 2 because it's equal to 2. And it goes up to infinity, which we can never equal, so therefore we'll have a parenthesis around it. So brackets are for closed circles, parentheses would be for open circles, and also for infinities. Write the solution to the inequality in interval notation. X is greater than or equal to 2.5. Close circle, everything greater than or equal to. In interval notation then, we go low to high, okay? And the low end is 2.5, the high end is infinity. So I'm gonna say bracket 2.5 comma positive infinity. The reason it got a bracket is because it's equal to 2.5. Infinity, we never say something can equal infinity because there's always a value higher. Okay, but that's my interval notation. Y is less than 4. I'm going to put a 4, open circle, and everything less. Y is less than 4 is any number lower than 4 but not equal to it. In interval notation, which is always low to high, this is the interval of my solution set. The low end goes down to negative infinity. The high end goes all the way up to 4. And then I use parentheses with 4 because it's not equal to 4, but just up to it. And the parentheses represents the exact same thing as the open circle does. And then infinities always get parentheses because we can never truly equal infinity. We can just always try to go lower, lower, lower. So, and that's what that means, infinitely low. So then that just gets a parentheses. Okay, you try to solve. 5w plus 6 is less than or equal to 4w minus 2.5, and graph the solution set, then answer in interval notation. Okay, so I'm going to move my w's left. W is less than or equal to negative 8.5. That's my solution set in graph form. And then in interval notation, I want to go low to high and represent the interval of solutions. It goes from negative infinity to negative 8.5, left to right. Okay? Left is on the left, right is the right bound. Okay? All right. Avram is delivering 90 pounds. Oh, you know what? I'm going to skip this one. Okay, on to example 5. Solving an and inequality. You can join two inequalities with the word and or the word or to form compound inequalities. To solve compound inequality using and, find all values of the variable that make both inequalities true. So find the solution to the compound inequality and write your answer in interval notation and graph on the number line. So and is going to be the solution to both. So let's try to figure out what the solution will be. So I'm going to subtract 1 and I get 6 divided by 2 and I get 3, and I'm going to swing the x to the other side. X is greater than 3. Divide by 3. X is less than or equal to 6. Okay, graph both. 3 is lower, 6 is higher. Set it up like a number line. And then x is everything greater than 3, so open circle and go all the way to the right. And x is everything less than or equal to 6, close circle, and shade everything to the left. Now, where is my solution set that satisfies both of these? That would actually be right here in the middle. It's everything that is satisfying x is greater than 3 and less than or equal to 6. X has to be in between those then. So ands are right in the middle. So we would say that it goes everything from 3 to 6 is my lower bound and upper bound of this region. And so that's my final solution. Parentheses 3 to 6 bracket. Okay, number 5. This is still an and problem because the x variable is sandwiched in between these here. So there's two ways that ands can be presented to you, either with the word and or in this compound inequality presentation right here. Now, what I want to do is I want to get x alone in the center. So whatever I do to the center, I have to do 3 times total. So if I want to subtract 1, I have to subtract it from the center and the left and the right. Okay. 5 minus 1 is 4. 13 minus 1 is 12. So my solution is going to be x is greater than 4 and x is less than 12, because right here I see x is greater than 4, and right here I see x is less than 12. All right, so 4, 12, x is everything bigger, x is everything less. So where is it true for both? Right in the middle, where I see both lines, because this is the solution to my 12, this is the solution to greater than 4, and so it's less than 12 and greater than 4 wherever you see both lines. Okay, so then we'll say from 4 to 12 with parentheses, because I use parentheses for open circles because they mean up to but not quite equal to. They mean the exact same thing. Where brackets and closed circles mean the exact same thing. All right, what's wrong with this? X greater than 4 gives us infinity to 4. Well, let's graph it first. X greater than 4 looks like this. So on the low end, I should have 4, and on the upper end, I should have infinity. Well, what was wrong with this then? Hey, it's backwards. This says from infinity to 4. That's from high to low, but I always want it to go from low to high. See how it's reversed? Okay, so make sure that on the left-hand side is actually the left-hand bound of your interval, and on the right-hand side is the right-hand bound of your interval. Okay, keep the left on the left and the right on the right. All right, let's turn it over. The OR inequalities. These solutions are wherever one or both inequalities are satisfied. So as long as you have at least one of the inequalities satisfied, then that is where you have solution. Let's subtract 7 from both sides. K is greater than or equal to -1. Let's subtract 8 from both sides. K is less than -5. Okay, let's graph both of those, and then let's write out our final answer in interval notation. Okay, so right now, -5 is less than -1. K is greater than or equal to -1, so close circle and to the right. K is less than -5, open circle and to the left. It looks like we have 2 intervals of answers then, because ORs are wherever one or both inequalities are satisfied. So therefore, because we have 1 and 1, then we need to make sure that we can answer and say that everywhere from -infinity to -5 we have solution, or from -1 to infinity we have solution. Let's go to B. Okay, solve both. Subtract 1. 15 is less than 5x. Divide by 5. X is greater than 3. Subtract 9. 3x is less than -3. X is less than -1. So -1 is lower than 3. Plot them in that order. At 3, x is everything greater. Open circle and to the right for every number greater than 3. X is less than -1. Open circle and shade to the left to answer for everything less than -1. All right, we need 2 intervals just like we did over here. Everything less than all the way up to -1. So left bound on the left, right bound on the right, parentheses always for infinities, parentheses for open circles. Okay, left and right, 3 to infinity. All right. Number 7, a no solution or all real solutions. These are your special cases. If you arrive at a false statement, such as 10 is less than 2, then the solution set for that inequality is the empty set. If you arrive at a true statement, then the solution set for that inequality is a set of all real numbers. Okay. All right, let's try 2 of those. So, for the first one, solve each inequality, describe the solution set using interval notation and in a verbal sentence, and then graph on a number line. Okay, so then I have an and setup. So I'm looking for the overlap, just like and requires both equations to be true. So I'm looking for that middle overlap where I have both equations, or two lines graphed. One for the one equation, one for the other equation. Okay? So let's see where that overlap's going to be. First thing I need to do is divide it up and then try to find my x and try to get that x alone. So add 4 to all three sides. Negative 20, negative 2x, 16. Divide by negative 2. Whenever you divide or multiply by a negative, you need to switch the direction of that inequality. Negative 20 divided by negative 2 is positive 10. Okay, this part's telling me that x is greater than or equal to 10, and this part's saying that x is less than or equal to negative 8. So on a graph, negative 8 is lower than 10, x is less than or equal to negative 8, x is greater than or equal to 10. I don't see any and. I don't see any region where x is bigger than 10 and less than negative 8. Bigger than 10 and less than negative 8? There's no such numbers. So my solution is no solution. There are no such numbers that are greater than 10 and less than negative 8 at the same time. Okay, next one is an or. Divide up the page and solve both sides. Times by 3 to get rid of your divide by 3. Divide by 4. X is greater than 3. Add 1. 2x is less than 10. Divide by 2. X is less than 5. Graph them. 3 is lower than 5. Plot them in that order. X is greater than 3. X is less than 5. Oh my! Ors work wherever there is one or the other one true. All the way down to negative infinity, I have one solution. From 3 to 5, I have two solutions true. And above 5, I have one solution true. So I have solution everywhere, all the way down to negative infinity, in between, and all the way up to positive infinity. So I'm going to say that my solution set is all real numbers. Okay guys, thanks for joining me.